In this video, we're going to describe the working principles of a Whitworth quick return mechanism. A Whitworth quick return mechanism is a device which converts a rotational motion to a reciprocation motion. During this reciprocation motion, the forward stroke takes longer than the backward stroke. This is why it's called the Whitworth quick return mechanism. As you can see in this animation, the yellow pinion gear drives the green bull gear. The green bull gear rotates around the gray boss, which is not rotating. A small black shaft, which is off-center, extends outward from the gray boss. The slotted plate in red is free to rotate around this black shaft. A white pin attached to the green bull gear is free to slide in the groove under the red plate and forces the red plate to rotate around the black shaft. Another white round pin is free to slide in the groove on top of the red slotted plate. A black link attached to this pin drives a ram, which is not shown in this animation. Let's increase the rotational speed and observe how the black link makes the forward stroke slower than the backward stroke. To understand how this is achieved, we will bring the rotation speed to 1. Now we can see a circle with red and blue segments separated by a purple line. The circle shows the path of the white pin on the green bull gear. The red segment corresponds to the slow forward stroke of the black link, while the blue segment corresponds to the quick return stroke of the black link. Since the red segment is longer than the blue segment and the white pin attached to the green bull gear rotates with a constant rotational motion, this means that the white pin spends more time to move on the red segment than the blue segment. This is also true for the white pin attached to the black link. This is why the black link moves faster when the white pin attached to the green bull gear is moving through the blue segment. Let's demonstrate how many milliseconds it takes for the white pin attached to the green bull gear to complete the motion through the red and blue segments. We will count when the black link passes through the purple line and wait for a complete rotation. As you can see, the red segment takes 207 milliseconds, while the blue segment takes 153 milliseconds. Another important feature of the Whitworth mechanism is the ability to adjust the stroke size. We will do this by first stopping the rotation by bringing it to 0, and then adjusting the location of the upper white pin. As you can see, once the upper white pin is closer to the rotation center, the stroke size of the black link is shorter. When the pin is moved away from the rotation center, the stroke size of the black link is longer. And this is how a Whitworth quick return mechanism works. We will show the practical application of this in the traversing head shaper animation to come.